Hello everyone, welcome back. So it has been a long time since the last video on this channel. So in this video we are going to discuss Hermann-Maugin notation system for crystallography. Right, so it is a very important topic and it has been asked multiple times previously in both civil services mains examination and Indian Forest Service exam. Right, now what is notation basically and Hermann-Maugin notation, and we will see certain examples under different crystal systems so that you will understand how this system works, notation system, right? So Hermann-Maugin notation, it is also called as international notation, right? So basically, first of all, what is notation, right? What is notation? So it is a standardized system to describe the repeating patterns within the crystal lattice. Describe the geometry of repeating patterns within the crystal lattice. Right? That is notation. So basically we are describing the symmetry elements of this crystal, of any crystal. So it is like a formula, right? So by looking at this particular notation, you will understand the symmetry elements of that particular crystal. So it is also called as international notation. It is symbolic representation of crystal symmetry. So it is a combination of numbers and letters to describe the symmetry elements in a crystal, right? So before we move forward, I will urge you to look at the previous videos. Just go through the previous videos where we have described the different crystal elements, right? Symmetry elements of the crystals. So once you understand the symmetry elements of crystals, mirror planes, right, rotational axis, so once you understand that, then you can come back to this video, right? So without knowing what are the symmetry elements of crystal, you won't be able to appreciate or understand this particular video. Okay, so go to the previous videos where we have described the symmetry elements of crystals. So once you have gone through them, then you can come back and look at this particular topic, right? So in this Hermann-Maugin notation system, first of all, how do you represent the rotational axis? So it is a symmetry element. How do you represent it? So we represent rotational axis with numbers 1, 2, 3, 4, 6. We don't have 5-fold or 7-fold rotational axis, right? So two-fold rotation, that means you have to rotate the crystal twice to get the same face again, right? So two-fold rotation, three-fold rotation, four-fold rotation, six-fold rotation, they are represented by numbers 1, 2, 3, 4 and 6, right? Then how do you represent the mirror planes in a crystal? So mirror planes are represented by the letter M, right? So represented by letter M, indicating reflection symmetry across a mirror plane. So mirror planes are represented by M. Inversion center. So inversion symmetry, where a point is inverted through the center of the crystal, it is represented by I, right, or I bar. Then roto inversion axis. So rotational axis and inversion operation. So both are happening. Rotation and inversion both are happening at the same time. So you will represent this by putting a bar on the rotational axis. So if it has two-fold rotation axis and inversion also, so two-fold roto inversion, so you will put a bar on that. If you have three-fold roto inversion, you will have 3 bar on it. If you have four-fold roto inversion, you will have 4 bar. Six-fold roto inversion, 6 bar. So roto inversion is represented by bar. Okay, so mirror planes, inversion center, roto inversion and rotational axis. Now for example, 2 by m, what does it represent? So it has two-fold rotation axis, because rotation axis is represented by whole numbers, right? 2 and if it has mirror plane, you will write M, right? Two-fold rotation axis, and also it has mirror plane. Now what does this slash mean? That means 2 slash M. That means the mirror plane is perpendicular to the rotational axis. So two-fold rotation axis is perpendicular to the mirror plane. So that is why you write 2 slash M. If the mirror plane was not perpendicular to the rotational axis, you will just write 2M. Okay. So that is the way of representing. Then if you have 4 slash MMM, it has 3 mirror planes, one four-fold rotation axis, 3 mirror planes, and one of the mirror plane is perpendicular to the four-fold rotation axis. So you write 4 slash M. So this mirror plane is perpendicular to the four-fold rotation axis. These two are not perpendicular, so they will be represented just as MM. Now what does this mean? 6 slash M. So 6-fold rotation axis is there, and the mirror plane which is present, it is perpendicular to the rotation axis, 6-fold rotation axis. So 6 slash M, right? So that is how you represent rotational axis and mirror planes, right? So each symmetry operation has a symbol. So for rotation axis, we have 1, 2, 3, 4, 6, right? If you have roto inversion, you will write bar on the top of rotational axis. So if it has two-fold rotation axis, two-fold roto inversion, you will write 2 bar. Three-fold roto inversion, 3 bar. Four-fold roto inversion, 4 bar, right? Center of inversion is represented by I. Okay, so these are the symbols that we use for notation under Hermann-Maugin system. Now just go through the examples so that you will understand how we use this system. Now first of all, if you have a crystal, now it is under orthorhombic system. So this crystal is from orthorhombic system. 7 crystal systems are there, total 32 point groups are there, right? So under orthorhombic system, let us take an example. So first step that you do is write down, so this is the first step, write down a number representing each unique rotational axis, right? So here you have 3 two-fold rotation axis. So these are unique rotational axes. So let me take another color. Okay, so you have this rotational axis, it is two-fold rotational axis A2. Here it is another unique two-fold rotation axis. This is another unique two-fold rotation axis, right? So you have 3 unique two-fold rotation axis. Then you also have 3 mirror planes. So one mirror plane is this one. This one is one mirror plane which is vertical. This is another mirror plane that is also vertical, and this is third mirror plane that is horizontal, right? So you have 3 mirror planes, 3M, and one inversion, center of inversion, right? Now how do you represent it under Hermann-Maugin system? So you first write down the symmetry elements present, then second, that mirror planes, how many unique mirror planes are there, right? Third step, you see if any mirror plane is perpendicular to the rotational axis, unique rotational axis, right? So if a mirror plane is perpendicular to the rotational axis or not, you should check that. Okay, so overall how many symmetry elements are there? So you have 3 two-fold rotational axis. So 1, 2 and 3. You have 3 two-fold rotational axis. 3 mirror planes are there. So 1, 2 and 3 mirror planes are there. Right. There is one center of inversion. Now there are 3 two-fold rotational axis. So you will write 2, 2, 2 unique two-fold rotational axis. So ये एक यूनिक रोटेशनल एक्सिस है C एक्सिस में, B एक्सिस एंड A एक्सिस, राइट? सो there are three two-fold rotation axis, unique rotational axis, and there are three mirror planes, right? And all of the mirror planes are perpendicular to the unique two-fold rotation axis. So you will write slash for all of them. So 2 bar m, 2 bar m, and 2 bar m. So the mirror planes, three mirror planes, they are all perpendicular to the unique rotational axis, two-fold rotational axis. How? You see here. So for this rotational axis, इस rotational axis के लिए कौन सा mirror plane perpendicular है? This one. This mirror plane is perpendicular to the rotational axis, this one. Now for this mirror plane, this is the this is the first rotational axis, this is the second rotational axis. For this rotational axis, two-fold rotational axis, this mirror plane is perpendicular. And for this third unique two-fold rotational axis, this horizontal mirror plane is perpendicular. So there are three mirror planes which are all perpendicular to the unique two-fold rotation axis. So you'll write 2 bar 2 slash m, 2 slash m, then 2 slash m. So that is how you write down the notation for this orthorhombic crystal. Now let us take another example. So first of all, let us see if it has any rotational axis. So पहले तो symmetry elements लिख लोगे. So it has one two-fold rotational axis, unique two-fold rotation axis, and it has two mirror planes. Okay, so where are these mirror planes? So this is one mirror plane, vertical mirror plane, and this is the second mirror plane. Okay, there are two mirror planes. Now, so first you will write 2, okay, and two mirror planes are there, you will write mm. And third step was to check whether any of the mirror plane was perpendicular to the unique two-fold rotation axis. So यहाँ पर दोनों mirror planes vertical हैं and the rotational axis is passing through C axis, right? So there is no horizontal mirror plane. ऐसा कोई mirror plane नहीं है. So that is why we are not writing 2 slash m, because there is no mirror plane which is perpendicular to the two-fold rotational axis. So two-fold rotational axis के साथ कोई भी mirror plane perpendicular नहीं है. So you will write 2 mm. So let us take another example. So it is under tetragonal system, right? So first of all, how many unique rotational axes are there? So there is one four-fold rotation axis. So here it is four-fold rotation axis. Okay, it is passing through the C axis. So one four-fold rotation axis is there. Then there are four two-fold rotation axis. There are four two-fold rotation axis. So one two-fold rotation axis is here, unique two-fold rotation axis. Then second two-fold rotational axis is here. Unique क्यों बोल रहे हैं? Because the faces they are different, right? So the rotational axis which is passing through the particular face, it is different from the other face of the crystal. So this is one two-fold rotation axis, unique two-fold rotation axis passing through the center of this face. This is second unique two-fold rotation axis. Then third unique two-fold rotation axis, it is passing through the edge, right? And this is the fourth two-fold rotation axis. So there are four unique two-fold rotation axis: 1, 2, 3, and 4. So first step is done. Second, you see how many mirror planes are there. There are 5 mirror planes. What are these mirror planes? कौन से mirror planes? So this is one mirror plane which is perpendicular or sorry, not perpendicular, that is vertical. So this is one mirror plane. This is another vertical mirror plane, second mirror plane. This is diagonal mirror plane, third one. This is the fourth one, right? So there are four vertical mirror planes. First one, second one, third diagonal, fourth one is also diagonal mirror plane. Fifth mirror plane is horizontal. Fifth mirror plane is horizontal. So there are five mirror planes, one center of inversion, four two-fold rotation axis, one four-fold rotation axis. Okay. Now there is also a center of inversion. Okay. Now you have to give the notation now. So one four-fold rotation axis, and there are unique rotational axis, two-fold rotational axis. Okay, four two-fold rotation axis. Now there are four two-fold rotation axis, but only two are unique. There are not four unique axes. See, ये वाला जो face है, this face is similar to this face, right? These two faces are same. Sorry, it was mistake on my part. There are only two unique two-fold rotation axes. Totally four rotational axes are there, but only two are unique, because this face, center of from the center of which the two-fold rotation axis is passing, this is similar to this face. So these two are same two-fold rotation axis. So अगर unique बोलेंगे तो there is only one. Okay, these two are same two-fold rotation axis because the faces are same. So this rotational axis and this rotational axis, they are counted as one unique two-fold rotation axis. It is passing through the edge. It is also passing through the edge, right? So they are two-fold rotational axis passing through the edge, but unique अगर बोलेंगे तो एक ही है because both of them are passing through the edges. So this is the second unique two-fold rotation axis. So there are four two-fold rotation axis in total, but if you say unique, there are only two two-fold rotation axis that are unique. So here, so unique two-fold rotation axis, there are only two. Total four हैं, but unique because ये वाला और ये वाला सेम फेस के सेंटर से जा रहा है. सो यूनिक जब बोलेंगे तो एक ही है. सो यू हैव हियर one four-fold unique four-fold rotation axis, one unique two-fold rotation axis, and another unique two-fold rotation axis. One is passing through the center of the face, second one is from the edge. And we have mirror planes, 5 mirror planes total, and there is a mirror plane perpendicular to each unique rotational axis. So if you see, four-fold rotation axis है, right? This is the four-fold rotation axis. This horizontal mirror plane is perpendicular to this four-fold rotation axis. It will pass through the, ये तुम्हारा four-fold rotation axis इसके बीच से जाएगा. So it is perpendicular, 90 degrees है, right? Now for this two-fold rotation axis, this mirror plane, this vertical mirror plane, it is perpendicular to this तो इसके सेंटर से जा रहा है, ये 90 डिग्रीज बनेगा, right? And for the two-fold rotation axis that is passing through the edge, for this diagonal mirror plane will be perpendicular. ये इसके सेंटर से जा रहा है. So this diagonal mirror plane will be perpendicular to this two-fold rotation axis which is passing through the edge. ये भी 90 degrees है. So we have three mirror planes that are perpendicular to the unique two-fold rotation axis. So you will write 4, 2, 2 for the unique rotational axis, M, 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 because the mirror planes are there, 5 mirror planes are there, and out of 5 mirror planes, 3 mirror planes are perpendicular to the unique two-fold rotation axis. So you write 4/M, 2/M, and 2/M. Now take an example of isometric system. So it is having more symmetry elements. So isometric system has highest number of symmetry elements. So इसमें देखते हैं. It looks very complicated, but if you study the symmetry elements, it is quite simple. So first of all, let us see how many rotational axes are there. So there are 3 four-fold rotation axes. So this is one four-fold rotation axis. तो ये एक four-fold rotation axis है because it is cubic system. All the sides are same. All the faces have same dimension. So this is one four-fold rotation axis. This is second four-fold rotation axis, and this is third four-fold rotation axis. So तुम्हारा A, B, C और X, Y, Z axis से जा रहे हैं. So they are passing through X, Y, Z axis, right? So you have 3 four-fold rotation axis. Now let us see how many three-fold rotation axes are there. So three-fold rotation axis are passing through the corners. So you have three-fold roto inversion. A bar है roto inversion axis है ये. So it is passing through. One is passing through this corner. Second one is passing through from bottom corner to top corner. यहाँ से ये वाले bottom corner से ये top corner जा रहा है. यहाँ पे ये bottom corner से ये top corner जा रहा है. Okay. And roto inversion axis, three-fold roto inversion axis, and third one is here. So it is passing from this top corner to that bottom corner. Okay, third one, and fourth one is passing for three-fold roto inversion axis is passing from this top corner to this bottom corner. So you have 4 three-fold roto inversion axis. 4 three-fold roto inversion axis, right? So you have 3 four-fold rotation axis, 4 three-fold rotation axis, and 6 two-fold rotation axis. So two-fold rotation axis देखो कहाँ कहाँ पर है, right? So one two-fold rotation axis is passing from this edge from the bottom. ये bottom edge से एक जा रहा है, right? This is passing from this bottom edge to this top edge. Second one is passing from this bottom edge to this top edge. Third two-fold rotation axis is passing from this side edge to this side edge, right? Then you have fourth two-fold rotation axis is passing from the upper edge to this bottom edge, right? Then fifth is passing from this side edge to opposite side edge. And where is the sixth one? So there are 6 in total. 6 two-fold rotation axes are there. So 1, 2, 3, 4, 5, and 6. So 6 two-fold rotation axes are there. And there are totally 9 mirror planes. Total 9 mirror planes are there. So let us look at the mirror planes. So one mirror plane, this is vertical mirror plane, एक हो गया. Second vertical mirror plane is this one, right? Third diagonal plane. Fourth, this one. Fifth is horizontal, right? Sixth one is this plane. Seventh one is this, right? Eighth and ninth. There are 9 mirror planes in total. So सबसे ज़्यादा mirror planes तुम्हारा isometric system में होता है. 9 mirror planes are, ये dotted lines जो है ना, the dotted lines, they represent the mirror planes. So total 9 mirror planes are there. Okay. Now, so there is a center of inversion also. So 3 4-fold rotation axis, 4 3-fold rotation axis, and 6 2-fold rotation axis. And you see there is a mirror plane which is perpendicular to the 4-fold rotation axis, क्योंकि 4-fold rotation axis 3 है लेकिन एक ही यूनिक है. There is only one, you can take it as only one unique, because ये वाला जो face है, this face and this face, they are all same. Cubic system है ना, cube में तो सारे side same होते हैं. So though there are 3 4-fold rotation axis, you can count it as only one unique 4-fold rotation axis. Now if you say roto inversion axis, there are 4 3-fold roto inversion axis. There are 4, but they are all passing through the corners, right? And all the corners are of same, because सारे faces same है. So there is only one, you can count it as only one unique 3-fold rotation axis. And 2-fold rotation axes are there. 6 2-fold rotation axes are there. And now you see the mirror plane, this, ये जो mirror plane है, this is perpendicular to this 2-fold rotation axis. For this, for this 4-fold rotation axis, this is, ये पहले वाले के लिए ये तुम्हारा mirror plane perpendicular है. For this second one, you have this mirror plane which is perpendicular. For the third one, you have this mirror plane which is perpendicular. So 4/m, because the mirror planes are perpendicular to the 4-fold rotation axis. So you also have 2-fold rotation axis. So 2-fold rotation axis के लिए भी तुम्हारे पास perpendicular mirror planes हैं. So for this, for example, for this 2-fold rotation axis, right? For this 2-fold rotation axis, you have this mirror plane, diagonal mirror plane, which is perpendicular. Okay. For this, you have, for this 2-fold rotation axis which is passing through the upper side, एक mirror plane ऐसा भी है जो ये है, this mirror plane is perpendicular to this 2-fold rotation axis. So there are mirror planes which are also perpendicular to the 2-fold rotation axis. So you will write 2/m. There are no mirror planes that are perpendicular to the 3-fold roto inversion. So you will not write 3/m. So you have mirror planes that are perpendicular to the 4-fold rotation axis and 2-fold rotation axis, but not for the 3-fold rotation axis. 3-fold roto inversion axis, not rotation. So that is why we write 3 bar. यहाँ पे 3 नहीं लिखा है, 3 bar हम लोग लिखेंगे. We write it 3 bar because it is roto inversion axis. 3 bar. So that is how you represent the symmetry elements of crystal under Hermann-Maugin notation system. So this is an important question in the examination. So you can give an example, जो simple orthorhombic system का जो simple example है, you can give that and write the theory part, right? So that was regarding the Hermann-Maugin system of notation. So that will be all for this video. Thank you very much.